Have you ever wondered how a game remembers your score or how a social media app remembers your name? The secret lies in one of the most basic but powerful concepts in programming: variables. Hey everyone, welcome back to Flow Labs. In our previous video, we learned how to write debug messages and comments. Today, we're diving into one of the most fundamental concepts in programming: variables. Now, don't worry if you've never programmed before or if math wasn't your favorite subject in school. I'm going to explain variables in the simplest way possible using everyday examples that anyone can understand. By the end of this explanation, you'll completely get what variables are and why they're so powerful in game development. Think of variables as magical boxes that store information for your programs. Just like these boxes opening up, variables hold data that your code can use and change. See this golden box opening first? Let's call this variable gold. In Unity game development, gold might store a player's treasure, like 150 coins they've collected. The green box finishing here represents our health variable. In real programming, whether it's a fitness app or game, health could store a percentage like 85%, showing how much energy a character has left. Now watch this blue box, we'll call this mana. In programming, mana often represents magical energy, storing values like 200 points for casting spells. Let me give you some real-world examples to make this crystal clear. Your wallet. Your wallet is like a variable called wallet. The type is money container, and the value might be $50. Tomorrow, you might spend some money, so the value changes to $30. The wallet variable name stays the same, but what's inside, the value, can change. Variables are incredibly powerful in games because games are all about things that change. Think about any game you've played. Your health goes up and down, your score increases when you do well, your level changes as you progress. All of these changing things are perfect examples of variables in action. Let's dive into the essential rules for naming things in programming and discover how the right name can make your code speak for itself. Rule number 1, variable names must start with a letter or an underscore. They cannot start with numbers. See how player name with P lowercase and N in uppercase and underscore score work perfectly? But 1233 gold and 9 lives break this rule. Rule number 2, no spaces allowed. Variables must be written as one continuous word. Use CamelCase like player health or underscores like game_score. Never write player name with spaces. Rule number 3, variable names are case sensitive. This means CamelCase player name and player name with P and N in uppercase are completely different variables. Each of these is treated as a unique variable by the computer, even though they look similar to us. Rule number 4, only use letters, numbers, and underscores. Special characters like dashes, dots, or symbols are not allowed. Player 1 and max health follow the rules perfectly, but player -name and score iterate at game will cause errors. Remember these 4 simple rules and you'll never have trouble naming variables in any programming language. In real code, you declare these variables like this: int gold equals 150, float health equals 85.0f, int mana equals 200. Variables are the foundation of programming. They let you name, store, and update any data your program needs. Think of this like labeling a box in your room. Int. This tells the computer, hey, I'm going to put a whole number in this box. It's like writing numbers only on the outside of your storage box. Int is short for integer, which is just a fancy word for whole numbers like 1, 2, 100, or 500. No decimals allowed. Gold. This is simply the name we're giving to our box. Just like you might label a box in your closet, winter clothes, or books, we're labeling this computer memory box gold. We could have called it anything: coins, money, or even treasure. It's completely up to us. Equals. This is not about math equations. Think of it as an arrow pointing into the box. It means put this value inside the box. It's like saying, take what's on the right side and store it in the box on the left side. 150. This is the actual value, the thing we're putting inside our labeled box. Right now, our gold box contains the number 150. Maybe the player has 150 gold coins in their game. Semicolon. This semicolon is like a period at the end of a sentence. It tells the computer, okay, I'm done with this instruction. You can move on to the next one. So int gold equals 150 simply means computer, create a box that can hold whole numbers, label it gold, and put the number 150 inside it. It's that simple. No complex math needed. Just think of it as organizing and labeling boxes in your computer's memory. Now that we understand variable naming rules, let's put our knowledge into action. In our Guess a Number game, we will now use variables to store our game data. So, before declaring variables, we usually place them at the top of a block or function. It's not a strict rule, but it's good practice. Why? Because it tells the program what kind of data we'll use, reserves memory, and keeps the code clean and predictable. It's all about writing smarter, more readable code. First, let's set up the boundaries for our game. We need two variables, one for the minimum guess and one for the maximum guess. Int minGuess equals 1, int maxGuess equals 1000. See how we're using clear descriptive names? MinGuess and maxGuess tell us exactly what these variables do. They store the lowest and highest numbers our player can guess. Next, we need a variable to store the player's guess. Let's call it playerGuess. Int playerGuess equals 50. For now, we'll set it to 50 as our starting guess. In a real game, this would come from player input, but for learning purposes, we'll use a fixed value. Notice how all our variable names follow the rules we just learned. They start with letters, use CamelCase, no spaces, and only contain letters and numbers. See that green underline under the variable name? It's not an error. It just means the variable isn't being used yet. You can ignore it for now, but once you use the variable, it'll disappear. Just make sure it's not still there when your project's done. Before we move forward, let me quickly clean up the code from the previous video to keep things neat and easy to follow. Now comes the exciting part. Let's use Debug.Log to display our game information in Unity's console window. This will show us how our variables work in action. Add these lines to your start method. Look at how we're combining text with our variables using the plus operator. This is called string concatenation. We're joining text and variable values together. Now let's see how string concatenation works in action. We start with the text game range in quotes, then we use the plus operator to join it with our minGuess variable, which contains the value 1. Next, we add another plus to join the text 2. And you can also notice there are space before and after the 2. It's because that is exactly what we want to do between words. And finally, we concatenate our maxGuess variable containing 1000. Watch how the computer combines these pieces, the text game range plus the number 1 plus the text 2 plus the number 1000. The result, one beautiful string, game range 1 to 1000, exactly what appears in our Unity console. This is the power of string concatenation, mixing text and variables to create dynamic messages. Or alternatively, you can write this using Debug.Log format, which we have learned in our previous video. So instead of concatenating minGuess and maxGuess using the plus operator, we can use placeholders like 0 and 1, wrapped in curly brackets. After the message string, we simply pass the variables in order. First the minimum guess, then the maximum guess. Look how elegant that is. It's a more professional and maintainable way to format your output. Both methods, using string concatenation with plus or using placeholders like 0 and 1, are technically correct and will work just fine. But the placeholder approach tends to be visually cleaner and easier to read, especially when your message gets longer or includes multiple variables. Now let's explore different types of variables by adding more data to our game. We've been using int for numbers, but there are other important variable types too. So to store text in a variable, we use the string keyword. Let's write string game status equals game started. Look at here. Game started, see how we put it inside double quotes? This is crucial. Any text should always be inside double quotes, but for numbers, we don't need them. We'll also declare another variable called attempts remaining, which equals 5. Amazing! Since it's a number, we don't require double quotes, just the number itself. And lastly, let's declare another variable named gameActive, which equals true. Since this is a Boolean variable, it can have only true or false values, nothing else. And now we're setting it to true, which later in our game will mean our game is currently active and running. So remember the pattern: int for whole numbers, no quotes needed; string for text, always use double quotes; bool for true false, no quotes, just true or false. Each variable type serves a specific purpose and has its own rules. Master these 3 types and you'll be able to store any kind of information your games need. Now let's display this information beautifully in our console. Perfect. When you run this in Unity, you'll see a beautifully formatted console output showing all your variable values working together. This is exactly how professional game developers organize and debug their games. And there you have it. We've mastered variables, the building blocks of all programming. We learned how to store numbers with int, text with string, and true-false values with bool. We've created our first game data structure and learned how to display it professionally. In our next video, we'll dive into building game logic using conditional statements, explore how variable scope affects behavior, and break down the key differences between the start and update methods in Unity. If this video helped you understand variables, smash that like button. Subscribe to Flow Labs and hit the notification bell so you never miss our latest tutorials. Drop any questions in the comments. I read every single one. Keep coding, keep creating, and see you in the next one.